Welcome, everyone. Today, we are unlocking the secret to making AI agents truly conversational. We will explore how to manage short-term memory using conversation buffer and window memory systems. Let's get started. To understand memory, we first have to understand the core limitation of large language models. They are completely stateless. Imagine talking to someone who gets amnesia every time you finish a sentence. That is how a raw LLM operates. To have a coherent conversation, the AI needs short-term memory. This type of memory temporarily retains and manipulates information relevant to the immediate task, like maintaining a log of recent conversational turns. By capturing these recent events, the AI can understand references like he or it based on previous context, creating a seamless, natural dialogue. Take a look at this comparison on screen. On the top path, a user sends a query to a standard stateless LLM. The result, it immediately forgets the past. However, on the bottom path, the user query flows through a short-term memory module before reaching the agent. This transforms our system into a stateful agent that successfully remembers context. It is a simple architectural shift that makes all the difference. Let's dive into the most foundational memory type, conversation buffer memory. The basics are incredibly straightforward. The system literally buffers, or stores, every single message exchanged. When the user asks a new question, the system takes the entire historical array of messages, appends the new question, and feeds everything into the LLM's prompt. Why do we use it? Because it is simple to implement and guarantees absolute accuracy for short interactions. No detail is left behind. However, as we will see, this raw buffering approach creates a massive scaling problem for long conversations. This flowchart visualizes the conversation buffer process. Notice how message 1 flows into message 2, which flows into message 3, and so on. They stack together sequentially. At the bottom, this entire stack forms a massive array that gets injected directly into the prompt. It is a snowball effect. The prompt payload strictly grows larger with every single turn. Why can't we just use a conversation buffer forever? Because of the context window problem. Every LLM has a hard limit on how many tokens it can process at once, whether that's 4,000 or up to 1,000,000 tokens. Even if you use a model with a massive limit, sending a 100 message history just to process the user saying thanks is terrible engineering. It explodes your API costs and drastically increases latency. Furthermore, research shows LLMs suffer from the lost in the middle phenomenon. If you stuff too much text into a prompt, the model pays attention to the very beginning and the very end, but completely ignores critical facts hidden in the middle. We must optimize. Here we see the inevitable results of uncapped chat history. As tokens increase, the system hits a context limit wall. When this wall is hit, 3 critical failures branch out: API cost explosion, high latency, and the dreaded lost in the middle phenomenon where accuracy plummets. This diagram clearly illustrates why raw buffering is not production-ready for extended use. To solve the scaling issue, we introduce conversation window memory. This operates as a rolling context window. Instead of keeping everything, it only retains a fixed, recent portion of the conversation. How does it work? It uses a first-in, first-out, or FIFO approach. When your defined window is full, the oldest parts of the context are simply ejected and replaced with the most recent ones. This is brilliant because it guarantees that your token usage, and therefore your costs and latency, remains strictly bounded. Plus, it mimics human attention. If we are troubleshooting a software issue, the steps we took 2 minutes ago are critical. Our initial hello from an hour ago is no longer relevant. Look at the elegant logic of the sliding window. On the left, old message 1 is being ejected into the trash using the FIFO principle. Meanwhile, messages 2, 3, and the new message 4 are safely held inside our active window, which is set to a size of 3. Only these highly relevant, recent messages flow into our optimized LLM prompt. The context stays fresh and lightweight. Let's deep dive into how this is actually implemented in modern frameworks like LangChain. We don't just blindly chop arrays in half. We use specialized functions like trim messages. You set a strict max tokens limit and apply a strategy called last. This tells the system to start discarding from the beginning of the chat history, ensuring the most recent messages at the end are preserved. But we must be careful. If we slice strictly by tokens, we might accidentally cut a conversation pair in half, leaving an orphan AI response without the human question that triggered it. To prevent this, we pass a parameter like start on equals human. This ensures the rolling window always cleanly begins with a user's prompt. This technical diagram outlines the trim message's logic. The raw message array enters the trimmer. Two critical rules are applied simultaneously. Strategy equals last ensures we keep recent tokens, and start on equals human preserves the conversational logic flow by not splitting question-answer pairs. They converge to output a clean, bounded context payload. Let's look at a real-time, highly practical use case, an IT helpdesk chatbot. Imagine an employee is trying to fix a VPN issue. They have been chatting with the AI for 30 minutes, generating 40 messages of deep, technical back and forth. If we used a standard conversation buffer, the 41st message would send pages of text to the API, costing a fortune and slowing the response. By implementing window memory capped at the last 6 messages, the AI perfectly remembers the specific error code the user just pasted and the troubleshooting step they tried right before that. It completely drops the routine password reset checks from 20 minutes ago. The user gets a lightning-fast, highly contextual response, and your infrastructure costs drop by 80%. Follow the sequence diagram to see the real-time helpdesk flow. The user sends their 41st message about error 809. The AI agent queries the window memory, which is configured to a window of 6. The memory instantly returns only messages 35 through 40. The AI uses this highly targeted context to formulate message 42, advising a registry update. The past 34 messages are completely bypassed, optimizing the entire cycle. To wrap up, memory design is critical for production AI. Conversation buffer memory is your simple, flawless tool for short tasks. But as soon as your users engage in long, continuous sessions, conversation window memory becomes absolute mandatory for controlling costs and avoiding the lost in the middle token crisis. This is the essence of context engineering, learning exactly what to retain and what to let go. As your architectures mature, you will eventually combine this short-term rolling window with long-term semantic vector databases to build truly brilliant agents. That concludes our training. Please like, subscribe, and visit quicktechie.com for premium certification prep, including extensive Q&A banks, full ebooks, audiobooks, full-length training videos, and interview guides to elevate your AI engineering career. Our final diagram shows the spectrum of memory systems. On top, buffer memory is tied to short chats. In the middle, our focus today, window memory utilizes FIFO to dominate long sessions securely. At the bottom lies the future, vector memory using semantic search for infinite fact retention. Mastering when to use each is the hallmark of a senior AI architect.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by Quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material. So this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see these are all Microsoft related certification. AB 730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have 5 practice paper. So click on the first practice paper, it would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepared for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.